Yo guys, it's been forever. It's been almost half a year, and I made a Rubik's Cube solver. So let's go ahead.
But let me go ahead and show you the project. So I'm just gonna feed in uh, a scramble, and let me just do the scramble first. And you probably will understand some of, like, at least a small part of what the video talks about if you don't know notations. And if you want to learn them, I do have a video, my second video on the channel, the brief basics of Rubik's Cube. You can watch that to learn notations really quickly. But you could also just go to a different channel or something, or just go ahead and skip that process altogether. But let's go ahead and look at this. This is just scrambling the Rubik's Cube, the scramble, and this is what the cube should look like after scrambling. So green, yellow, yellow, blue, blue, orange, yellow, red, and then vice versa. Like the same for every other thing. So we're going to start off with a cross. And you just follow the steps. Alright, so F prime, D, R prime, F, F, D, R prime, R, D, B prime, D, 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 F prime, L prime, D, F prime, D, D, F, F. And it does repeat a lot of the stuff. It's not the most optimized thing in the world, but it gets the job done. So that's what I'm mostly caring about. Alright, so the cross is done. As you can see, it did finish the cross. Now for the corners. So just copy it down. I'll probably speed things up for you. Okay, so that's just the demonstration, and yeah, it's already been 4 minutes, but it shouldn't be too bad. Alright, let's hide that terminal. Alright, the first part that I went for, the first thing I thought of doing, and I thought was the most important thing to do first, was probably setting up how the cube knew what it looked like, or how the computer knew what the cube looked like. So I went for a dictionary with the key as the side of as the color of the side, and then had a list of values. And instead of 9 values for each of the tiles, I just had 8 because the center is always going to stay the same with how I coded it. I didn't have any rotations put in. So there's corner, the first corner, first corner, first corner, first edge, second corner, second edge, third corner, third edge, fourth corner, fourth edge. And then I just had it like that. So 0, 1, 2, 3, 4, 5, 6, 7. And that for each side. So white, green on the front, and then green, red, blue, orange, and then yellow with green on top. Alright, so that didn't take too long, just telling you how that worked. And let's get to the next part. So after that, I needed a way to turn the cube, well, in the computer at least. So I went ahead and made turns.py, and I imported the cube so I could actually change the values from cube.py over here, turns.py, and I had a bunch of code actually. Let's see how many lines. Ooh, this is even more than all my logic. 469 lines of code, all just so I could turn the cube. And I probably could have made less lines by like changing the counterclockwise to just doing the normal 3 times. But how I did it was I would just turn that side clockwise. I would just like rotate the pieces around and all that. And I just did it like this. Used Copilot. It actually helped me a lot. GitHub Copilot. It helped me not waste time at all. So I could just I typed this in once, and then I could just tab it over for every single thing. And then over here, this one I just had to manually pick out the white pieces connected to green, the orange, and all that, the red, yellow. And it took a bit of time. It took a lot of time actually, but eventually got it done. And it was around the same thing for the counterclockwise. I just changed the rotation, changed the order of stuff, and I just had to do a bunch of copy pasting and like a bunch of stuff like that. And the F2, like the double moves, I just called the function twice. And I could probably have gotten away with just calling the counterclockwise for the counterclockwise. I could just call the normal clockwise 3 times, and it would have done the same thing. But I didn't realize at the time. I'm stupid. That's why. Okay, so the turns, that's over with. I'm not really going to go over the code too much and how it works, just you can try to figure that out yourself. But yeah, maybe if I get enough time, I'll probably go over an in-depth tutorial on how to like actually code this for yourself and how everything works. So after that, the next thing I did was scrambling. So that was, I first named it scramble.py because, well, it was mainly for scrambling. Then I realized I had all these algorithms here. So I just changed the name to use alg, so to use an algorithm. And all I did was take a string in. This is a string. I should probably put that there, I guess. I don't know. It's a string. Wait, that doesn't work. I guess that doesn't work. Alright, I guess that, oh, wait. Yeah, I don't remember how this works. But yeah, I just have an algorithm over here, and it turns into a list by just splitting it by a space. I had to lower it first, just to make sure this all works properly. And I just manually went in and just R2, RC, all that stuff. I didn't do anything fancy. So that was the use algorithm.py. And then next, let's go ahead and go to all the algorithms. For this, I took most of my time. Like the main reason why this actually took so long, this algorithm part, was because instead of like doing the algorithm just once, I had to actually change it around for the middle layer, and I had to rotate it around. Like, cause I can't just rotate the cube in my code. I have to like move the side differently. So if I wanted to do the green red, instead of doing the normal like, I would just do like that. Instead, I have to do it upside down, and then for the sides, I had to do it from the back, from like the side. It's like really weird notations and everything. So that's why that took so long. But I just manually typed in everything. You guys can like pause the code, copy the algorithms if you want. I wouldn't use this for an actual solve. The finger tricks suck, and it's way too much memorizing. But maybe in the future, maybe in my next video, I'll make a Rubik's Cube solving tutorial. Probably just beginner method for now, and then I'll move on to the CFOP and FTOL. But that's much later on. So then orientate corners, permutate edges. I didn't want to make it too intuitive because the more intuitive it is, the more logic I'd have to add for the computer to understand it. Because, well, what's intuitive for us takes a lot more code for a computer to figure out. Okay, so that's the algorithms done. Then let's go to the actual logic. And the main.py just runs it all. The inputs the scramble, this actually does a scramble, prints out the cube, and then actually solves it. So let's go to solve.py. Over here, this is just calling each function and all that, and then it prints the cube at the very end. So let's start with the cross. The imports I did were the cube, all the turns you could do, the use algorithm function, and then all the algorithms that I hard-coded in. So first of all, the first step was to do the daisy cross, and if you don't know what that is, that's just putting all the white edges on the yellow side, like that. Of course, without the little pattern, but yeah. So basically, I just went around the whole cube, like the white side, looked for all the white, the color white, and I moved it to the yellow side. I did that anyways, like even for this, just because I wanted to make the logic a bit easier on my side. But yeah, and then just going through each one, going manually through. That's how I first started this. I just hard coded in most of the stuff, didn't use that much dry concept. Don't repeat yourself concept. I didn't use much of that. I didn't follow it much at the beginning. I thought it was just like too much work trying to think of how to make the code shorter, but eventually I did figure it out. The green side, I did something pretty neat, I'd say for myself at least, where I just moved all the edges out to one side and then I do the move. I made sure to clean the side. that I was clean the yellow side from what I was turning to make sure there was nothing important there. I would just move move the down there until there was an empty space that I can move it freely, and then I just do all this code. And I did the same for red, blue, and orange. And then the move cross. The move cross function, what I did for that was just once you get the daisy cross, it was just aligning each side starting with green. If this matches, then move it over. If it doesn't match, then I'd have to move the sides around. And then I'd move to orange, move it over, keep going around looking for stuff. And now I need to figure out how to solve this. How to solve it. So yeah, and that's basically it. So that's all the move cross did. It just did all that stuff. And the cross was just combining both of them together, the cross function, to clean up my code just a little bit. And then we'll get into the corner front, corner right, corner bottom in a bit. But first, we're going to move on to the corner logic. So this was just a while true statement with another while loop inside it, a double while loop. That's the best way I can think of doing this. So I'd go through. I just move the down layer until I found a white edge, or I mean not a white corner. Yeah, okay, I forgot all my algorithms. But yeah, so I just moved it down there until I found a nice a white edge. And when I did, I would just use one of the three algorithms, depending on where the white color was. So if it was on the front, then I would do this corner front algorithm, which is pretty simple. It should be pretty intuitive for most people. If it isn't, then try figuring it out like this. The C stands for counterclockwise, by the way, if you didn't realize that. So just D prime, R prime, D, R. And the corner right, just D, F, D prime, F prime, if the white was on the right. And the corner bottom was just doing R prime, D prime, R, D 3 times. So yeah, I am messing this cube up way too much. And that's just the corner bottom, corner right, corner front stuff. And I just went to do that over and over, just for each possible like front, right, and all that. So that's what I did. And depending on like what colors it were, I'd have to move the top layer to get the right slot above it, so I could do the algorithm successfully and all that, align it properly. And I just did that for each. What is this? Oh yeah, for each corner bottom, corner right, corner front. So yeah, and then afterwards, I just like make sure that. I just had this little part and the less than 5 part, I less than 5. I had that part to make sure that when I did like more than 4 moves without finding a white corner, then I'd end the for loop, not the for, the while loop. So that's just what I did over there. So yeah, and then when I found something, I just reset the I value. So I could restart that for counter, the I counter. And then over here, this took a decent amount of my time, but not too much. So I had this fix equals false, and basically, if I had to fix it, if I had to like move some corners out, I'd call this. I'd restart the function. But if I didn't need to take anything out, then I'd just break the loop, and I'd finish that step. But the main part of this code was just I'd look for all the edges, all the corners. I'm getting all this confused. I'd go through all the white corners, make sure they're in the right slot. If they weren't, then I'd take it out using the corner right, and and then I'd I'd toggle fix to true to basically restart the code, restart this step. I mean, and when I restarted, it would automatically just fix the edge, not the corner, the corner. You remember, we're on corner right now. But yeah, it's the same thing went for the edge. I just used the same while loop state stuff at the bottom too. I just checked through all of them, use the algorithm, and I used the middle layer algorithm over here. Depending on which colors it were, I'd go through that. And the code looks really messy, even for me. Even to me, it looks messy, and I'm the one who wrote it. But I just got the two colors on the edge, and I just look at it, keep orientating the bottom layer until I found an edge without yellow on it. So that's just what this if statement is. If I did find one without yellow, I set the I counter to 0. And same goes on for all this. And I use that algorithm. And the same thing for the fix equals false, fix equals true, all that stuff. I just check all the middle layer slots. Then we went to the yellow cross. This one wasted a lot of my time, at least 2 hours of my time. So I had a counter for how many yellow edges there were on the yellow side. If there was let me see, if it was an edge, then I'd increase the counter on the yellow side. And then if the counter was equal to 0, then that would be in the dot case, and I'll do the algorithm for that over here, dot case. If there were 2, then it would either be the line or the L case. So if for the line, I just check while not, and then this whole thing, I don't want to get into it too much. I don't want to confuse you too much, but basically, if there was a yellow edge on the 5th or 7th slot, or if there was a yellow tile on the 5th or 7th slot, and there was a yellow tile on the 3rd slot, then that would do true. But if it wasn't, then I'd keep turning the bottom layer until it was true, and then I'd get out of the while loop, and I'd move on to this. If it was 7 and 3, then that was line case. If it was 5 and 3, then it was L case, and I'll do the algorithm for each one separately. Then the orientate yellow corners. That was just OLL for the corners. This is OLL, the first part of it, the cross, and then the corners. For this one, I was surprised to find a nice solution that didn't take too much hard coding. Just a little bit of a couple of while loops, which I'd say is pretty bad, actually, and then 4 loops inside the while loop. Okay, yeah, that's pretty funny. And that would probably slow down my code a lot. But yeah, so for I in range 8, I just count again like before. And then in the while loops, I'd count again, just looking for the corners. If it was not equal to 1, if all the corners weren't there and if it was in between 1 and 4 corners, then I would just keep doing the algorithm if I found a corner on the right side on the bottom, so over here. Then I do the algorithm, the permutate corners algorithm. But if there was a fish case, then I would move the fish over, so the head would be over here, and I do the algorithm over there. And that's how that works. Then the permutate yellow corners. That was just permutation PLL. That one, I had a lot of code probably and I probably could have reduced it, but basically I just had to look for 2 matching corners and move them in the back, do the algorithm. If there weren't any matching, I just do the algorithm and then restart, or in this case, I would just have to move the D layer once and then do the algorithm again. For the edges, around the same thing, I just had to find a 3 match. In this case, I just had to look for an edge that matched the corner. And if there were more than 2 that did that, like more than 2 sides, that would mean it was solved, and I'd move on. But if it wasn't solved, if there was only 1 match, then I'd go through, find where it was, move it in the back, do the algorithm, and if there was no 3, then I would just do the permutate edges, and then I would restart the while loop until it was solved. Then I would just align the yellow layer, and that's all my code. Uh, yeah, so I went through all my code surprisingly in only 22 minutes. I thought it would be at least 30. That is a long video right there. But yeah, if you want to see a more in-depth tutorial, probably a playlist going through each separate thing in this project, and actually go over the code a little more in depth, then like, comment down, and all that stuff. Comment down what you want to see from me in the future. And yeah, I'll see you in the next